Hello there, my name is Maher Haddad. Today I'm going to show you how to configure spanning tree, rapid spanning tree and Portfast. So let's go to the lab. So the lab scenario is you work as network engineer in a company. You have 3 switches connected to each other and having redundancy. So this is our lab. You have switch 1, switch 2 and switch 3. They are all connected to each other. So there is redundancy. And there is PC1, which is my PC connected to SW1. And there is another PC2, which is connected to SW2. So the first task we have to do is to configure trunk between ports of connected switches. So the trunk should be on SW1, F01, F02, F01, F02 over 2, F0 over 1 and F0 over 2 on SW3. Okay, so interface fast Ethernet 0 over 1, switch port mode trunk, switch port trunk encapsulation.1q. Then I go to 0 over 2 trunk.1q. SW2 switch port mod trunk, switch port mod okay. This is because this is 2950, it will take directly .1q. So fast Ethernet 0 over 2 and then SW3 okay. So let's verify. Show interface fast Ethernet 0 over 1 switch port. So as you can see here, operation mode is trunk.1q, and we do for fast Ethernet 0 over 2 also trunk.1q. Let's do on show interface fast Ethernet 0 over 1, and here I write trunk instead of switch port, and then it say that port F0 over 1 is encapsulation 1q and it's trunking. And I do the same for 0 over 2. 0 over 2 also is trunking status and encapsulation 1q. And of course on SW1, if you want to, I can do also show run. Then over here you can see interface fast Ethernet 0 over 1, which is trunk, and 0 over 2, which is trunk. Okay, very good. So this is first step done. Now configure access mode for port connected to PC1 and PC2. All other unused port on all switches should be disabled for security reason. So we come back here. This port should be configured as static, and this port on SW3 should be configured as static because it's connected to a PC. So let's do it. Interface fast Ethernet 0 over 3, switch port mode access, and the same on SW3. Interface fast Ethernet 0 over 3, switch port mode access. Now if I do show interface fast Ethernet 0 over 3 switch port, you can see here it's statically it's access. So static access means it has been hard coded as access. I do the same for SW1. Show interface fast Ethernet 0 over 3 switch port, and also it's static access. Okay, so this is done. Now the second part of the question is all switches should disable, all ports on unused port on all switches should be disabled for security reason. Okay, so if I do show IP interface brief on switch SW1, I see that I'm using 1, 2, 3, and the rest should be disabled. So from 4 to 48. Interface range fast Ethernet 0/4 to 48, and I do shutdown. So that's for security reason. I'm shutting down all of these interfaces. Now I go to SW2, show IP interface brief. Then we see that 1, 2 are used, and then from 3 to 24. Interface range fast Ethernet 0/3 to 24, shutdown. Now I go to SW3, I do show IP interface brief, and I see that 3 is used. Then from 4 to 24 should be shut down. Shut down. Alright, so now if I do show IP interface brief, I see that all are administratively down now. That's good. Show IP interface brief, that's good. That's good. Alright, now number 3, which switch has been elected as root, bridge, and why? Because we have redundancy on this, so then the spanning tree should be working. So one of the switches will be the root bridge. So let's see who is this one. So let's check on SW1, show spanning tree, and you can see here that this is not the root bridge. The root bridge is the one who has this MAC address with this priority. And you can see here there is a block for one port, so this is mean that this is not the root bridge. SW2, show spanning tree. And yes, this bridge is the root bridge, so this one is the root bridge. And they say why. So let's check first the priority. It's 32.768. Here, sir, it's 32.769. Also this one 769. And let's check this one. Okay, so they have the same root priority. So then we have to look to the MAC address. The MAC address of the root bridge is 001B 0. So let's write it here. SW1. This is the MAC address. SW2. This is the MAC address. No, sorry. This is the MAC address. I'm mistaken. Sorry. Again, the bridge ID is here. This is for the switch. So that is the priority, and let's write them. And to see why it's selecting SW1 and SW as a root bridge. So SW1. This is for SW1. SW2. I go to SW2. And then SW3, bridge ID. Alright, so let's check. The priority on SW1 36.865. So of course, because SW1 has priority higher then SW2 and SW3, then this one is out of the election. Then the election is between these two. They have same bridge ID. Then we have to look to the MAC address, and because this one has lower MAC address, 001B is lower than 001F, then this is the reason why SW2 has been elected as the root bridge. Okay. Now, number 4, ensure that SW1 is the root bridge for the default VLAN. Okay, so I go to SW1 and I write this comment: spanning tree VLAN 1 is the default VLAN, and here I say root. I can say root primary. Okay, that is one of the comments I can do, or I can say priority. I can directly change the priority, but here it should be incrementing by 496. So let's do it the first way, which is root primary. So in this case, I'm saying for the switch, you should be the root bridge. So if I do show spanning tree now, you see now that it has been changed, that this is the bridge. This bridge is the root, and you can see here that directly when I say that it's primary, the priority has decreased. So it was on SW1. If you see here on SW1, it was priority 36,865. It became 24. So if I copy this one, I put it in place of this one, then this one is lower than those two. Then this is why SW1 has been elected as root bridge. Okay. Now, which port end up by being blocked and why? Blocked should have a K. Okay, so let's check which one has been ended as blocked. Of course, SW1 should have all ports forwarding because it's a root bridge, show spanning tree, and it is forwarding. SW2 forwarding, then SW3 had the port 0/2. This port has been blocked, and the reason why it is blocked, when we have a root bridge, all ports of root bridge become designated port forwarding. These two ports, because they are directly connected to the root bridge, should be root port, and they are forwarding as well. So then there is this over here, should have one port which should be blocked to not have redundancy and looping because we have redundancy. So which port should be, this port or this port? And this is based on, if we go back to what we saw here, so SW2 and SW3. So this is based on who has the higher, the lower root bridge ID. Who has the higher lower bridge ID. So in case, for example, in this case, SW2, if you can see, they tie the priority, but this SW2 has lower than SW3. Then because it's lower, it's better than SW3. Then SW3 will block the port. So this is why F0/2 of SW3 has been ended by blocking. Okay. Now, to verify that STP is working well, issue a repeated ping from PC1 to PC2, then disable the cable between SW1 and SW3. How long does it take for the failover? Okay, so I have to go now to, this is PC1, I go to command prompt. I do ping 192.168.0.253 minus T. Means it's continuous, and I'm going now to disconnect the cable between SW1 and SW3. Okay, the lab is a little bit far from me, so I had to go, and now the cable has been yeah, I took out the cable from this port as from this interface, and you can see that the network is out now. But yeah, so you have 1, 2, 3, 4, 5, 6 requests timed out before the network came back on. And if we check now, so we have this was blocked, but because we cut the cable over here, then if we check now again, and you see that which was blocked F0/2 and become here forward. Okay, so it takes 6-7 around 6-7 timed out request timed outs, about maybe 15 seconds to have the failover working again. Now I will plug again the cable and come back. Okay, the cable is back now to its place. So as you can see here, if I do show spanning tree, so now this port, which has been unplugged, now is plugged and it's in listening. Then this means that it's listening for the BPDU, and now it should go to learning. Learning means it is learning the MAC address, but still we have outage in the network. And after that, it's forwarding, means it's up. So we can see here that it is up. Okay, so let's go to the other steps. Ensure that ports connected to PC1 and PC2 moved directly to forward state. So as I show you at the moment that it takes a little bit to go from direct on the switch to be in the forwarding state. So Cisco they have a very good configuration, which is Portfast, which make the port directly on the switch which is connected to the PC directly to go into forwarding. And because sometimes PC now is becoming faster than switches. To do that, I go to interface fast Ethernet 0/3, which is connected to PC1, and I say here spanning tree and Portfast. Okay, and when you put this command, it gives you a warning that Portfast should only be enabled on port connected to a single host. Connecting hub, concentrator, switches, bridges, etc. to this interface when Portfast is enabled can cause a temporary bridging loop. Okay, so you have always to do Portfast only on connected host. So I did this on PC1. Let's do it on PC2 now. SW3 interface fast Ethernet 0/3, and here I say spanning tree Portfast. Okay, that's good. Now, to ensure faster switching conversions in case of failure, apply rapid spanning tree on all switches, or RSTP. So I just showed you here that it took a couple of seconds before it makes the failover. So there is a new configuration we can do it, which is rapid spanning tree, where it goes only maybe for one request timed out, and even it doesn't show any request timed out. So the failover is very much faster than on a normal spanning tree. To do that, I have to go to SW1, and here I have to say spanning tree mode rapid per VLAN spanning tree, and I have to apply this to all switches. I think I'm not able anymore to go to, because I'm in telnet, to SW2 and SW3. try to ping them. Okay. Close this and try to okay. Because we changed it to rapid spanning tree, it looks like the other switches stopped the communication. So here I have to say also on SW2 configure terminal spanning tree mode rapid pure VLAN spanning tree, and I have to do the same for SW3. Configure terminal spanning tree mode rapid per VLAN spanning tree. Okay, let me just make the sizes. Okay, so now a rapid spanning tree has been applied to the three switches. If I do now on SW3 show spanning tree, yeah, it has been applied, and here you can see when you see the H P2P, this means that it is connected to a PC, which is in this case on F0/3. Alright, now the last question. Repeat now point number 6 after rapid spanning tree has been enabled successfully. How long does it take for the failover now? So number 6 is we have to make a ping and then disable the cable between SW1 and SW3. Alright, so let's check now if it goes faster. So here I say ping 192.168.0.254 minus T, and I will go and disable the cable. Okay, the cable is disabled now. As you can see, we don't have any request timed out, so my cable now is not anymore connected. And if I go to SW3 now, I see that it was blocked. If I do now again show spanning tree, it become forward. So you can see here that there is no any missing of timed out. I will put it back to see if we can have one request timed out. 1 second. Okay, now it's back. It's connected again, and also we didn't have any request timed out. So here we can see now again that it has been blocked. So this is how rapid spanning tree work, which is much faster than the spanning tree. So this is all the lab. I hope you enjoyed it. This was Maher Haddad. See you in the next labs.